I am Ennemcien. Continuation of radioactivity. Now let us calculate disintegration energy during alpha decay. Alpha particle is the nucleus of helium. This is a commonplace knowledge. A combination of two protons and two neutrons. That means mass is 4 units and charge is 2 units. So when a nucleus emits or disintegrates by emitting alpha particle, mass number reduces by 4 units and charge number reduces by 2 units. This is alpha disintegration. A definite energy value is involved in this process. Emission of energy is involved. Now, for the time being, let us assume that the parent nucleus is at rest and it emits an alpha particle. Then the parent nucleus will recoil just like the firing of a gun. Let capital M is the mass of the daughter nucleus formed after emitting the alpha particle. We get the daughter nucleus. Let its mass be M. V be the recoil velocity of the daughter. Small m be the mass of the alpha particle. V alpha be the velocity of the alpha particle. Then total disintegration energy of the process means that is the sum total of kinetic energy of alpha particle and kinetic energy of recoil of the daughter nucleus. That is the disintegration energy involved in the process. So before that it should obey conservation of momentum. So total final momentum must be equal to total initial momentum. Initially the parent nucleus was at rest, so its momentum must be 0. Total final momentum is momentum of the daughter plus momentum of the alpha particle. So according to the principle of conservation of momentum, mv momentum of the daughter plus mv alpha momentum of the alpha particle. This is the total final momentum must be equal to total initial momentum, that is 0, from which you can find the recoil velocity of the daughter. V equals minus mv alpha by m. Put it as equation number 1. Then the disintegration energy Q equals kinetic energy of the daughter plus kinetic energy of the alpha. That is half mv square plus half mv alpha square. Just you substitute for v from this equation. You get Q equals half m into minus mv alpha by m the whole square plus half mv alpha square. Or Q equals, you can simplify it to get half mv alpha square into small m by capital M plus 1. Put it as equation number 2. You can do it yourself, the simplification steps. Now half mv alpha square is the kinetic energy of the alpha particle. Now we know that small m is 4 units mass of alpha particle. Mass of the parent, mass number of the parent, let it be A. Then mass of the daughter will be A minus 4. Capital M is A minus 4. So you substitute these values here. In the place of M you put 4. So this is kinetic energy of the alpha particle, K alpha into M4 by capital M is A minus 4, where A is the mass number of the parent nucleus, plus 1. You can simplify it to get Q equals A by A minus 4 into K alpha. You can remember this formula. It may appear in your board exam or entrance exam. You can use it. one more point, that is the density of nuclear matter. Say, for example, calculate the density of iron nucleus. Uh, Density, a nucleus is assumed to be spherical in shape. Radius of that nucleus is given by this formula, 1.1 into 10 raised to minus 15 into a raised to 1 by 3. This is a constant factor. A is the mass number of the nucleus. So this is the formula for calculating radius of a nucleus. See, this factor can be 1.2 or 1.1. You can take it as 1.1. So 1.1 into 10 raised to minus 15 into a raised to 1 by 3. For iron, A equals 56. So that radius of iron nucleus is 1.1 into 10 raised to minus 15 into 56 raised to 1 by 3. You will get it as 4.208 into 10 raised to minus 15 meter. 10 raised to minus 15 meter is called 1 Fermi. Then volume of the nucleus, V equals 4 by 3 pi r cube, spherical volume. So density rho equals m by V. That is, substitute for this V, 3m by 4 pi r cube. Substitute all these things. 3 into m is 56. This is in atomic mass unit, convert it into kilogram. So this into 1.66 into 10 raised to minus 27 divided by 4 pi into 4.208 into 10 raised to minus 15 cube. The final answer will be 2.97 into 10 raised to 17 kilogram per meter cube. What a density! Density of iron, rock, etc. is in the range of 2,000 to 3,000 only kilogram per meter. This is 10 raised to 17. So 1 teaspoon full of nuclear matter may weigh the mass of 5 or 6 elephants. Such a dense matter is nucleus. See that? Wonderful. Thank you.